This lesson is going to show us how to solve for an angle, that is, all possible values for an angle, if we're starting with the trigonometric ratio. And so in this question we're saying given tan of this angle, theta, is equal to negative 1.19175, where 0 and 360 are the boundaries of theta. That means it must be in between 0 and 360, a positive angle. We're asked to determine all possible values for this angle and then sketch the angles in standard position. Well, to begin with, I guess all we need to do is we just need to say, all right, if the tangent of theta is negative 1.19175, then the angle must be equal to the inverse tangent of negative 1.19175. So entering this into our calculator, we'll say second function, so the inverse tan of negative 1.19175. And that gives us an angle of negative 49.9999. So we're going to assume that this is theta equals negative 49.999 degrees, which we will round to negative 50 degrees. Okay, well, that is an answer. I mean, there's what the calculator gave us, but unfortunately, that degree measure doesn't fit our restriction here, which says that our angle has to lie between 0 and 360. That is, it has to be a positive angle. So I guess we need to do a little more investigation here. So what I'm going to do is this. I'm going to go ahead and sketch on the coordinate grid where negative 50 degrees actually lies. And we know that negative will move in this direction. And so the terminal arm is probably going to be somewhere around there, and that is negative 50 degrees. Okay? And if I recall the cast rule, well, C, A, S, and T, well, the tangent of theta up in the start here, it was negative. And that would match quadrant 4. So this is quadrant 4. This is 1, and we've got 2 over here, and 3 down here. That would match quadrant 4 because cosine is the only trig ratio that is positive in quadrant 4. So the tangent ratio would be negative, and that does correspond with an angle in quadrant 4. So I guess the only thing we need to do is need to sort of find an angle that matches this restriction. So all we need to do to find the first angle is to say, all right, what is the positive coterminal angle for negative 50? That is, what other angle has that as its terminal arm, except instead of going in the negative direction as negative 50 would, we're going to go in the positive direction. So solving for that angle, I'm just going to say, all right, what is 360 degrees minus this 50 degree piece at the end? And we're going to see that that is equal to 310 degrees. So this angle measure here of 310 degrees is our first solution. Okay, that is one of the possible values. And if we actually took the tangent value of 310 degrees, you would find that it's negative 1.19175. Okay, well, is there another value that would match that? And we just have to look at our 4 quadrants here and look at the cast rule, and that's going to help us decide where the other angle would lie. Okay, now our original angle with our original terminal arm is here in quadrant 4 because the tangent ratio was negative. So what other quadrant has a negative tan ratio? well, it's not quadrant 1 because everything is positive there. It's not quadrant 3 because the tangent is positive there. So it must be in quadrant 2 because only the sine ratio is positive in quadrant 2. So that means that if I draw a terminal arm here in quadrant 2, this angle here would have to match this related acute angle here, right? Because that was the angle made with the x-axis. So there's a 50-degree angle measure here as this related acute angle. All right, so what is the angle measure of this angle from here and then stopping at this terminal arm right there? Well, to find that, we'll solve for that second measure. I'm going to take 180 degrees and then I'm going to, again, back up by 50 degrees. And that gives us 130 degrees. So there is the second angle that we're interested in, right there, terminal arm in quadrant 2, and it is 130 degrees. Okay, so given tangent theta equals negative 1.19175, determine all possible values for theta, and then sketch the angles in standard position. If this sketch looks a little complicated, we'll just sketch them very quickly over here, and we'll do it one at a time. The first solution, 310 degrees, terminal arm over here, and there is 310 degrees. The second solution in quadrant 2, there's the terminal arm right there, and this angle here is 130 degrees. So those are the two solutions for this problem. Just be careful, check your answers with the cast rule to make sure that your positive and negative ratios are correct, and that's it.